Hi, welcome back to fourth quarter. This starts off a little bit of the review of what we were talking about before. We're talking about the degree of each term in a polynomial. So if we have x to the third, that's a third degree. And remember, third degree polynomials are called cubics. And then we have second degree, and they were called quadratics. And if we have first degree, oh, that's not a D, sorry, first degree. And first degree are the things that we started with, which are linear. So what are the names of each type of polynomial? There we go. What polynomial do you already know how to graph? I hope you said linear. Remember, y equals mx plus b is the basic equation for a linear function, where b is the y-intercept and m is the slope. Now we're going to talk about quadratic graphs and how to do them. The parent graph is y equals x squared, just like when you have a linear parent graph, it's just y equals x. So, what type of shape does a quadratic form? Let's take a look. So let's just plug in numbers to the y equals x squared parent graph. And if I plug in -2, remember it's -2 squared. So if you're going to plug it into your calculator, you have to put the -2 in parentheses, because we actually want -2 times -2, not 2 squared and then making it negative. So -2 times -2 is 4. -1 times -1, hopefully you're saying is 1. 0 times 0, 1 times 1, and 2 times 2. So there are the numbers. So let's put those on the graph. Remember, x, y are our coordinates for an order pair. X is this axis, the horizontal, y is the vertical axis. So -2, 4 is 2 to the left and 4 up. And we just put 1 point there. And -1, 1, 0, 0, 1, 1, and 2, 4. So if we connect our points, we get this shape graph. And notice I put arrows at the end because it extends forever in those directions. So what type of shape does this form? These are called parabolas. And so it forms a parabola, and parabolas are symmetric. So we could have put it here. The vertical line that divides a parabola into equal halves is called the axis of symmetry. And usually we show it by putting a dotted line in. So in this case, this is the vertical line that divides the parent graph in half, which is also the y-axis, or where x equals 0 would be the equation for that line. The axis of symmetry is defined the equation of the vertical line that cuts the shape in half. So in this case, it's x equals 0. I went 0 over to draw that line. All right, so parent graph of y equals x squared, there it is drawn again. The axis of symmetry, and I just did that, is x equals 0. Every parabola either has a high point or a low point. The first graph, the parent graph, has if you think of this, this is the low point. Nothing is underneath that, right? So it has a low point. This low point is called the minimum. Excuse me. On this second graph, there is a, hopefully you said high point, which is called the maximum. I know we're tricky when we come up with names of things, right? The minimum or the maximum is the vertex of the parabola. And we haven't talked much about the vertex, but the vertex of the parabola is always on the axis of symmetry. And it's that point right there, either the high point or the low point. So the vertex is the coordinates of the point where either the minimum or maximum occurs. So in this case, in both of these cases, the minimum in this one is at the point 0, 0, and the maximum at this one is at the point 0, 0. So it's that point where the minimum or the maximum occurs. That is called the vertex. So now I want you to take a minute and write down if these parabolas have a minimum or a maximum and what that value is. So put me on pause and you decide and then come back. So I wrote the minimum value and the vertex for all of these. So get them all written down. You'll see if you notice, the minimum or the maximum is the y value of the vertex of all of these parabolas. All right, so now we're going to graph a little more than the parent graph. We had y equals x squared as a parent graph. Now we're x squared plus 1. So let's plug in numbers. So if we put in -2, again, we have -2 in parentheses squared plus 1, which is 4 plus 1, which equals 5. -1 squared plus 1 equals 2. 0 squared plus 1 equals 1. 1 squared plus 1 equals 2. And 2 squared plus 1 equals 4. Excuse me, equals 5. I guess I can't add 4 and 1. So let's graph these. So -2, 5, -2, 1, 2, 3, 4, 5, 2, 5, -1, 2, 1, 2, and 0, 1. So I don't think I said this on the last graph, but you'll notice I'm not making a sharp V. Absolute value graphs give you a sharp V, remember? This is a rounded bottom, or kind of a U-shaped more than a V-shaped. So what's the vertex here? Well, that's the very low point, which is 0 over and 1 up. What's the axis of symmetry? Again, axis of symmetry is the point where we could fold it like butterfly wings and it would be exactly the same on both sides. So in this case, the axis of symmetry is x equals 0, which it was on the other one too. And you notice that 0 is right there. There is a minimum or maximum. Well, it can't go under that, so there's a minimum. And what is that value? The minimum value is 1. Where does that 1 come from? Right there. So minimum value is 1. That's part of the vertex number, 0, 1. And now, last time we added a 1. This time we're going to change it by putting a number in front of the x squared. So -3 x squared. So -3 times -2 squared, which is -3 times 4, which is -12. -1, please be plugging this into your calculator on your own, and you could come back and check to make sure all your values are the same as mine. So go ahead and put me on pause. Hopefully our values matched up. So let's plot these points, and I know my graph only goes to 10, so we're going to be a little under it. -2 and -12, so I'm going to say right about there is 11 and there is 12. So -2, 12 would be right about there. I'm going to do 2 -12 also at the same time. and then -1, -3, which is way up here, and 1, -3, and then 0, 0. So there are my points. And there would be my parabola. Now, if you notice, we flipped it around. So what's my vertex here? My vertex is 0, 0. Axis of symmetry, still, my axis of symmetry hasn't changed. This is still it. So we have x equals 0 from there. Is there a minimum or maximum? You bet yeah, it's a maximum this time. And what is that value? 0, which comes from right there. So there is my parabola. And take a guess as to why it flipped over. So what about this one is different than the parent graph that you think it made it flip over? And if you said there's a negative, that is true. The negative value in front of the x squared is what makes it flip over or reflect over the x-axis. So 1/2 x squared we're going to graph this time. Last time we had -3, this time we're doing 1/2. So if I plug in -4, and you see I changed my number slightly because these are all numbers that are divisible by 1/2, so they work a lot better. So if I put in -4, I get, whoops, go ahead and you plug them all in and then come back and see if we match. So use your calculator and plug them. And there's my parabola. Make sure yours matches, and then you try to fill in the vertex, axis of symmetry, min, max, and what is the value. So put me on pause, fill that next part in, and then hit play again when you're ready. All right, there's the values you should have. Vertex 0, 0, axis of symmetry, x equals 0. It is a minimum, and my minimum value is 0. All right, that is all for today. There is a graphing quadratics worksheet that hopefully you have that you can start working on.